Hello Cardinals, it's me, Mr. Ernst, and in this video we are going to be talking about how to square a number and how to find a square root of a number. And we're going to start this lesson off with a review of exponents. Most of you guys are familiar that if you have 3 raised to the power of 1, you're just going to have a single 3, multiplied by nothing. 3 to the power of 2 means we have 3 times 3. 3 to the power of 3 means we have 1, 2, 3 3's all being multiplied together. And 3 to the power of 4 means we have 1, 2, 3, 4 3's all being multiplied together. What you may not have known is that each one of these exponential numbers can represent a measurement in different dimensions. Boo-wee-oo. So for example, 3 to the power of 1 means a one-dimensional measurement. In other words, a straight line. This is one dimension that is 3 units long. 3 squared is a way of measuring a two-dimensional object. You not only have 3, just like up here, but this also has a second dimension, which causes it to turn into a square. So now we have 3 on this side, and we have 3 coming down here. 3 squared. Aha. 3 to the power of 3 means we are making a three-dimensional object, which would look something like, let me see if I can do this. Boop, boop, boo. So 3 to the power of 3 makes a three-dimensional object where we have, once again, we have this value down here is a 3. We have this vertical value is still a 3, but now we have this depth. Now it has this weight to it. It's a three-dimensional object, so we have 3 to the power of 1, 3 to the power of 2, and 3 to the power of 3. And as much as I would love to try and sketch out what 3 to the power of 4 is, we don't really know what the fourth dimension looks like yet. Supposedly, this is supposed to be a representation of what 3 to the power of 4 would look like. An ever-changing, really weird-looking shape that's just kind of jiggling around all over the place. But that is just a theory, a math theory. Meanwhile, back in the regular world, back with these ones, this is where these terms come from. The term squaring a number, or even cubing a number is the other one. So squaring and you have cubing a number comes from these two. They actually have special names. When you square a number, you are always raising it to the power of 2 because it creates a square. Squaring a number means raising it to the power of 2 because it creates a two-dimensional square. If you cube a number, it means raising it to the power of 3 because it creates a three-dimensional cube. Okay? Now, of course, this video is not concerned with cubing, not yet. We are only concerned with squaring. So we're going to get rid of everything that's not squaring. We're going to focus on just the second dimension today. We don't want to get too crazy here. No fourth dimension, no third dimension, and no first dimension. We're not really worried about that. Just the second dimension today. So 3 times 3 is equal to 3 squared, okay? Keep in mind the area of this square. The area of this square is going to be equal to a side length times a side length. So 3 multiplied by 3, which means the area of this is going to be 9, which is, 3 times 3 is, well, it's equal to 9. So again, squaring a number means multiplying it by itself, and it comes from the fact that it makes a square. You are making a square with those numbers. So for example, 5 times 5 is the same as 5 squared, which on the geometry side makes a square. Wow, my squares are really rectangular today. A square where both sides are 5, which means the area of that square is 25. Cool? So that is what it means when we square a number. And that's going to be important for us to understand what the root of a square is. Okay? So once again, we're kind of reverting back here. So 3 times 3 is 9. Okay? That means 9 is a squared number. It's a number that's formed within this square. Cool? The square root of 9 is the side length of this square, the number 3. To give you another example, again, if we have, let's do 4. I'm going to actually start erasing this stuff. So we're just working with the exponents now. And let's move this over here. Whoop. So once again, 3 squared is 9, and the square root of 9 is 3. Another example here would be, let's say 4, whoops, let me get my actual pen here. 4 squared makes a square where all the side lengths are 4. So 4 squared would be the area of this, or in other words, 16. So 4 squared is equal to 16. The square root of 16 is one of the side lengths, which is 4. So the square root of 16 would be 4. Now the way that square root is written, so I've got 16 here. The way that you write the square root in like an equation is with what is called a radical. A radical looks like a division sign, except it's got this sassy little hand down here. This is a radical. Division sign, radical. This means the square root of 16. So if I ask you, what is the square root of 16? You know the square root of 16 is equal to 4. Another way you can think about this is when you're thinking of square root of 16, you're thinking of what number times what number is equal to 16? What number multiplied by itself is going to give me 16? Well, it's not 2, because 2 times 2 would give me 4, so it's not 2. It's not 3, because 3 times 3 would give me 9. No, the square root of 16 would be 4. Okay? We're going to go over just a few more examples to make sure that this is coming across clear. There is, but I did want to show you guys the example of how this looked. You know, what the geometry side of this stuff is. All right, a few more examples here. Here's a square, and the area of this square is, let's say, 49. Whoops. The area of this square is 49. What is the square root of this square? Or in other words, writing it out in algebra, so this is geometry. Writing this out in algebra, what is the square root of 49? In other words, what number multiplied by itself is going to give me 49? The answer to that would be 7. 7 is the square root of 49 because 7 multiplied by 7 gives me 49. The square root of 49 is 7. So again, this is kind of the geometry side over here. This is what's happening with the geometry. This is what's happening with the algebra. Next one, the square root of, let's say, 64 is equal to what? What number multiplied by itself is going to give me 64? This would come out to the number 8. So the square root of 64 is equal to 8. Remember, this little sassy division sign is referred to as a radical. Okay? Final example we'll take a look at here. What would, let's say, 9 squared be? What is 9 squared? Or in other words, 9 times 9. 9 times 9 will come out to be 81. On the flip side, what is the square root of 81? This would come out to be the number 9. So see how they kind of like almost reverse themselves. That's why we're doing both squaring and square roots. They undo themselves. 9 squared is equal to 81, and the square root of 81 is equal to 9. So that is, in a nutshell, squaring and finding the square root. Thanks for watching.